Welcome to this explainer. Today, we're diving straight into exactly why quantum computing has officially crossed a massive threshold. Listen, we are moving out of the realm of purely laboratory research and right into a critical commercial imperative for business leaders everywhere. Now, you might hear a topic like this and think, okay, but isn't quantum computing still decades away? Isn't it locked up in some experimental lab? Well, we need to shatter that assumption right out of the gate. The reality on the ground has fundamentally shifted, even in just the last year. To put this into perspective, quantum computing is projected to create up to $2.7 trillion of economic value worldwide by 2035. Yes, trillion with a T. That is a staggering number. And what it tells us is that the cost of ignoring this technology is monumental. We're talking about enhancing current industry use cases and unlocking entirely new ones across finance, logistics, and life sciences. So, let's break this complex trillion-dollar topic down into 5 logical steps. 1. The quantum tipping point. 2. A trillion-dollar opportunity. 3. Who is using quantum? 4. The hybrid computing bridge. And finally, 5. Your next steps. Let's kick things off with Section 1, the quantum tipping point, moving from the lab to the enterprise. Right, so before we get into the trillions of dollars, let's do a really quick level set on our terms. Quantum technology actually covers 3 main areas. You've got quantum computing, which uses quantum mechanics for massive performance boosts, quantum communication, which is all about securing data transfer, and quantum sensing for hypersensitive measurements. But for this explainer, we're zooming in on computing. Why? Because a massive 90% of current startup investment is pouring directly into that specific area. And what's truly fascinating here is the dramatic shift in who is actually using this stuff. Right now, 72% of quantum computing use is at companies majority owned by private entities. That is a massive pivot from just a few years ago when public sector orgs, like government labs and universities, were running the show. The private sector has officially taken the wheel.
Which brings us nicely to Section 2, a trillion-dollar opportunity, focusing on the flight of private capital.
The momentum we're seeing right now is just explosive. Private funding for quantum technology startups absolutely skyrocketed to $12.6 billion in 2025. To put that into context, that's over 6 times higher than the previous year. We're witnessing capital markets, venture capitalists, and corporate investors flooding into this space like never before, while government funding has dropped to just 3% of the total.
But here's the catch. This isn't just a broad scattering of seed money. Capital and talent are consolidating rapidly. Roughly 60% of that 2025 investment was concentrated in just the top 10 mega deals. And we're seeing major mergers and acquisitions accelerating, like IonQ acquiring Oxford Ionics. The key takeaway for you here is that the barrier to entry is rising fast. The ecosystem is maturing and consolidating around a few highly capitalized leaders. Let's move right along to Section 3, who is using quantum? We're going to look at real-world industry applications.
The heavy hitters are already on board. Over 300 global organizations aren't waiting around to see what happens. We're talking about innovation-driven companies like Airbus, E.ON, and JP Morgan Chase. They're actively collaborating with tech providers right now, moving past one-off science experiments and actually embedding quantum solutions directly into their end-to-end workflows.
To understand why they're moving so fast, just look at sectors like chemicals and life sciences. With classical computing, discovering a new drug often relies on testing assumptions. A lot of trial and error. But with quantum approaches, they can directly simulate the underlying physics of molecular interactions. You aren't just guessing anymore, you're simulating reality, making drug screening significantly faster, much more targeted, and way less costly.
And we're seeing this real-world traction across several incredibly complex sectors. In travel and logistics, companies are using quantum to solve massive combinatorial calculations. Think incredibly complex routing constraints or scheduling conflicts where a tiny incremental improvement saves millions of dollars. Or in financial services, where institutions are building quantum-enhanced models to capture edge case risks that classical computers just choke on.
But for the financial sector, it's not just about optimization. It's about survival. They're urgently reassessing their security architectures ahead of what's known as Q-Day. That's the inevitable moment when quantum machines become powerful enough to break the complex math behind standard public key cryptography. So for finance, quantum is both a massive analytics tool and a critical catalyst for risk transformation.
So how do you actually deploy this? That brings us to Section 4, the hybrid computing bridge, integrating the future today.
A lot of leaders assume they have to wait to rip out and replace their entire tech stack with some futuristic quantum mainframe. You absolutely don't. The most credible path to generating value right now is hybrid computing. It's a strategic integration of your existing classical systems with new quantum capabilities.
Think of it as a strategic bridge. You don't throw away your high-performance computers. Instead, those classical systems handle the bulk of the computation and orchestration. And then they apply quantum selectively, sending only the absolute hardest, most complex subproblems over to the quantum system.
It really boils down to 3 highly digestible steps. Step 1, classical preparation. Your standard computer sets up the problem and does the pre-processing. Step 2, quantum processing. Those insanely complex constraints are processed by the quantum machine. And step 3, classical completion. The quantum outcomes are translated back into standard bits and seamlessly integrated right into your existing workflow. It's the ultimate team effort.
Finally, let's wrap things up with Section 5, your next steps and the true cost of inaction.
Your strategic game plan here is clear. Treat quantum as a capability to build today, not a sci-fi breakthrough to wait for. You should prioritize those hybrid applications we just talked about in simulation, optimization, and risk. And the best part? You don't need to buy a massive quantum computer. The quantum as a service cloud market is booming, letting you test things remotely. But to do that, you need talent, developers, and business translators who can actually apply this to your specific industry problems.
There is a quote from the source material that just completely hits the nail on the head regarding your bottom line. It says, "Companies that delay their adoption of quantum computing may find themselves competing for scarce talent, limited partnerships, and maturing platforms, often at a higher cost of entry. The ecosystem is locking in right now. If you wait, you're going to pay a massive premium just to catch up." So, as we close out this explainer on what is literally a multi-trillion-dollar commercial tipping point, I want to leave you with one final, provocative thought to consider for your own organization. Are you waiting for the future, or are you building it? Thanks for joining us on this deep dive.